We want to get rid of all of this in a minute. Okay, and so when we create a new charm, we're going to give it a dictionary entry saying this charm has an augmentation of attack 3. So this becomes immediately better and more effective in both implementation, maintenance, readability, all that jazz. We reduce our signal noise so that when you look at it at a glance, you can say, what does this charm do? Oh, it augments the attack by 3. And if we come into our fists, you can see this side by side, just how much clearer and cleaner this is as an implementation. So we'll come in here and we will implement our dictionary, public fists, and let's cheat a little bit. Copying over the bits we need. Alright, so same thing here. Fists technically have an attack boost, but it's 0. Let's make it 1. And get that into that. Alright, so everything's looking pretty good. So things are much cleaner. And we're going to just hammer home this point every time we see the old code. That we're replacing all of this, these flags and these doubles, which is a few lines of code. Oh, I forgot what our hammer was. Hang on. 2. Alright, so the hammer has an attack strength of 2, or an attack boost of 2. Alright, refactorable. And then over here, this is going to be a player wearable, so we've got one extra bit in here saying the anatomy, telling it where it goes. So it has an attack boost of 1. Then import our inventory augment effect type. Get rid of this guy, something the whole block of code, change that back over to 1. And so now the items only have the augmentation effects that apply to them. And there's no other noise inside of these classes to distract us from what's actually happening. We got one more. And attack boost of the hat is also 1. Import that type. Get rid of all this. Make that 1. Alright, so we refactored our items and their kind of makeup to be a lot more concise, a lot more readable, and a lot more maintainable. So we're going to call that a success. I'm going to go ahead and remember to delete this because we no longer need it. Okay, so now let's get back to using that to make our algorithm a little smarter. So all these are going to look like this. Weapon dot oops, hang on real quick. Alright. So contains key attack. So if our weapon has this key inside of its dictionary, then we want to grab the value. Otherwise, return 0. Then we do the same thing with the outfit. And still x.value dot action effect dot contains key attack, then sum action effect attack. Oops, hang on. All right. So what we should see, hopefully immediately, is that now if we were to copy this into the other methods, the only thing that would change would be this type. So we've refactored down our call to only have one variance, being the enum, which is great because that's going to allow us to write a helper method where we can say public double calculate action boost, and we'll take in an augmentation effect. Let's call it effect. We'll copy this whole bit of code here we'll paste it into our helper method. We're going to replace all these calls to the augmentation effect with the effect we're passing in. I'm just going to return weapon boost plus outfit boost plus inventory items with a boost. Alright, give me 2 seconds to okay, so now we've got to calculate action boost. Let's make this very explicit because we might have very similar calls in the future. Calculate action boost from items. Copy that guy. So now we can have our var boost is equal to calculate and then pass in the inventory augmentation effect of attack. right? So we've taken what was going to be a lot of copy pasta redundant code, and we first refactored our items to be a little more intelligent and abstracted out their behavior to a dictionary with a type, and that type gave us a point to pivot off of. So when we came back into our player abstraction and we had our 4 actions, we can now take that algorithm. So we're saying all of this is an algorithm for calculating the total boost for a given property: healing, repairing, negotiation. We can take all that and we can abstract that out into its own method. So we'll keep this here in case we want to come in and debug and see the boost value before it gets applied, which is, I tend to like to do that. There's always going to be a desire to be super clean and do one of those, which is great. It just makes it more difficult to jump into this to see what the resulting value is. Not a huge deal, but this is a little clearer for our purposes as far as saying it does this, then this gets applied to this. All right, so now we can take this guy, replace all this, replace all this, replace all this. Take this augmentation effect, and say heal, repair, negotiate. Plus that boost, plus that boost, plus that boost. All right, so last week when we looked at algorithms, we said, hey, the simplest algorithm is just going to be return a double value, right? Return the number 20, return 3. And we still have that in some places, but now we're seeing how this calculate action from boost algorithm is a little more complicated. And all the more reason to have it in one place, and all that logic and math and decision treeing, have it happen here, because it could become more complicated as we add more rules, and we want that to naturally flow downstream to anything consuming it. We don't want to have to go around correcting algorithms in different places when they're doing the exact same thing. It's a great way to introduce bugs and other not fun times. All right, so let's go ahead and try this. We restructured the code quite a bit, and we need that kind of smoke test to see if what we've done produces the same result. We don't have any tests set up. Not really the point of these sessions to do much testing, but ideally you would know that, hey, this should be the value 17 or whatever it is. So we ask Gary to fight. Gary fights and returns 8 damage. That is, that's already weird, because he returned 7 damage before. So let's go back and see if we've done something correctly or incorrectly. Alright, so Gary attacks for 8 damage. Let's go and equip all of our gear. Gary puts on his Sunday best. Good job, Gary. Gary fights. Well. And Gary turns 19 damage. Okay. So we managed to get a few more points of damage. We want to figure out where those came from.